So for the first 5, if you want to determine if the sides make a triangle, you're going to add the 2 smaller sides together. So for this first example, the 2 smaller sides are 9 and 12. So 9 plus 12 has to be greater than the third side, which is 15. So if we add 9 and 12, we get 21. Is it greater than 15? Yes, this is a triangle. Same thing for number 2, add the 2 smaller ones, and it has to be greater than the third. When you add them, you get 20. That is greater than 13, so yes, it's a triangle. 21 plus 28, is it greater than 35? Yes. 3 plus 8 is 11, which is greater than 10. Yes, it's a triangle. And then lastly, 9 plus 10 has to be greater than 18. It is, so yes, it's a triangle. For numbers 6 and 7, we're doing Pythagorean theorem. So remember, Pythagorean theorem is a squared plus b squared equals c squared. C is always going to be the hypotenuse. A and B can be interchanged. So I'm going to label like this. If you said that A was 7 and B was 5, we'll still get the same answer. So when I set this up, I'm plugging in 5 squared plus 7 squared equals c squared. 5 squared is 25. 7 squared is 49, and that equals c squared. When I add those together, I get 74 equals c squared, and I'm just solving for c, so to get rid of the squared, I need to take the square root. The directions say leave in simplest radical form, so I'm just going to leave this as square root of 74, because if I check my list of perfect squares, so 4, 9, 16, 25, 36, 49, 74 can't be divided by any of those, so this is as simplified as it will get. For number 7, same idea. C is going to be the hypotenuse. A and B can be interchanged. So when I set this up, I'll have x squared plus 40 squared equals 50 squared. So then I square 40 and I square 50. This time it's a little different though, so I need to subtract 1600 from both sides. I end up with x squared equals 900. And then again, to get rid of the squared, because I just want to solve for x, I take the square root and I get 30. So since it's a whole number, it's okay to write down 30 instead of the radical 900. The next section, 8 through 11, is all about your trig functions. So remember, you get these formulas on the test. I'm just going to write up here our little trick we use to remember it, so SOHCAHTOA. Remember, you start by looking at the angle, and then you want to label your triangle. So the opposite side is always across from your angle. The hypotenuse is always across from the 90-degree angle, and then the last side is adjacent. To determine the trig function you're using, you're looking at which sides have labels. So if you look here, adjacent is 20, opposite's 13. Hypotenuse doesn't have anything out there, so we're really not interested in the hypotenuse. So if I have adjacent and opposite, that is going to be tan, because it's the TOA part. So you start off by writing tan, the angle, equals, and then it's opposite over adjacent, so 13 over 20. Now some of you will recognize that if you're solving for an angle, you should use the inverse. If you set it up like this, you should notice that you need to get tangent away from x. We do that by doing the inverse, so tan inverse, 13 over 20. Then you're just going to type that into a calculator. Remember that whatever calculator you're using, it needs to be in degrees. When you do that, you get 33.02, and the directions say to round to the nearest tenth, so it would just be 33.0. For the second one, again, mark your angle. This side is opposite. Across from the 90-degree angle is hypotenuse. The third side is the adjacent side. I have a label with opposite and hypotenuse, so that means that I am using sine. So sine your angle equals opposite over hypotenuse. if I want to solve for x, I have x divided by 40. So the opposite of dividing by 40 is to multiply by 40. These 40s cancel out. So 40 sine 75 equals x. Again, make sure that your calculator's in degrees, and you would get 38.6. For number 10, if I label this side's opposite, this side's hypotenuse, and this side's adjacent. This time, I have adjacent and hypotenuse with labels. If I look, I'm using cosine. So cosine 28 equals adjacent, which is x, over hypotenuse, which is 39. If I have x divided by 39, I want to solve for x, I would multiply by 39 on both sides. 39's cancel out, so I have 39 times cosine 28 equals x, and you just type that into your calculator, which is 34.4. And then last example for the trig section, I label, so across from the angle is opposite, across from the 90-degree angle is hypotenuse, and then lastly I have the adjacent side. I have opposite labeled and hypotenuse labeled, so those are the two I want to focus on. Opposite and hypotenuse means use sine. So I have sine 48 degrees, opposite is 40, x is hypotenuse. To solve this one, I need to multiply both sides by x because I don't know what to do with the 40, so we're just going to start with this. I have x times sine 48 equals 40. If I continue solving for x, I divide both sides by sine 48, and then those sine 48s cancel out. So I have x equals 40 divided by sine 48. If I type that into a calculator, I get 53.8. The next section has to deal with special right triangles. These two formulas will be given to you on the test. So here's the 45, 45, 90, and then here's the 30, 60, 90. You always want to start these problems by labeling your triangle. So for number 12, across is a 30, 60, 90. So across from 30 is always x. The hypotenuse is always 2x. And then the last side's always x square root of 3. Now, you're going to ignore their labels, so don't look at this or this until the very, very end of the problem. Whichever side has a label and a number, you're going to set those two equal. So right now, 2x equals 24. So I'm going to solve for x. X equals 12. Once you have x, you're going to take it and you're going to plug it into each of your labels. So I'm going to plug it in here and here. So for this side, when I plug it in, I get 12 square root of 3. Now, it says label this where the x blank is. So 12 square root of 3. When I take x and I plug it in here, I get 12, which is the y blank. So 12. Same idea for the next one. So for this next one, I want to label, this is a 45, 45, 90. So for this problem, across from x square root of 2, across from the right angle is x square root of 2. So across from the right angle, x square root of 2. The other two sides are labeled as x. Again, don't look at these labels that they have on them until the very, very end. Whichever side has a number and a label, you're going to set equal to each other. Solve for x. So x and square root of 2 are multiplying. The opposite is divide. When I divide, these square root of 2's cancel out, and so do these square root of 2's. So x equals 27. Now take that and plug it in everywhere you labeled an x. That means this side's 27, and this side is also 27. So where the x blank is, I'm going to put a 27, and where the y blank is, I'm going to put a 27. This one is also a 45, 45, 90. So across from the hypotenuse, across from the 90-degree angle is the hypotenuse, which is always x square root of 2. This side's x, this side's x. Again, we're not looking at these until the very, very end. So wherever you have a number and a label, you set those equal. I don't need to solve for x because I already have x equals square root of 6. So now I'm going to take this, and anywhere I have an x for my formula, I'm going to plug that in. So right here, this side is square root of 6. This side is square root of 6, square root of 2. Square root of 6 times square root of 2 is square root of 12. If you think about your perfect squares, 4, 9, 16, 25, I can divide 12 by 4. It's 4 times 3. The square root of 4 is really just 2. So this side is really 2 square root of 3. And that answer goes in the y blank. This side is square root of 6, which really goes in the x blank. On the next example, again I have a 45, 45, 90. Across from the right angle is x square root of 2. The other two sides are x. Don't look at these until the very, very end. Wherever you have a number in the label, you're setting them equal. Square root of 2 and x are multiplying. The opposites divide. And since we're solving for x, we'll divide by square root of 2. These square root of 2's will cancel out. So now I'm left over with x equals 34 divided by square root of 2. But we're not allowed to leave radicals in the denominator. So I multiply by square root of 2 over square root of 2. I multiply across the numerator. 34 times square root of 2 can't be combined because they're not both in a radical. So they just sit beside each other. 34 square root of 2. Square root of 2 times square root of 2 is square root of 4. And square root of 4 is really just 2. Lastly, 34 divided by 2 is 17. So 17 square root of 2 is our x. So now I take this, and anywhere I see an x labeled, I plug it in. So both of these sides are 17 square root of 2. So where there's the y blank, I'm going to put 17 square root of 2. And where the x blank is, I'm also going to put 17 square root of 2. 16 is a 30, 60, 90. Across from the 30 is x. The hypotenuse is always 2x. The last side's always x square root of 3. Where there's a number and your label, you're going to set them equal. I need to solve for x, so I'm going to divide both sides by square root of 3. These square root of 3's cancel out. So now I have x equals 42 divided by square root of 3. But you can't leave a radical on the bottom. So we're going to multiply by square root of 3 over square root of 3. When you multiply across the numerator, you get 42 square root of 3. When you multiply across the denominator, you just get 3. And then 42 divided by 3 is 14. So x is 14 square root of 3. So now I take this and I plug it in to my formula anywhere I see an x. So for this side, I have 14 square root of 3. For this side, I have 2 times 14 square root of 3. I can only multiply these two together since they're both outside of a radical. So that's 28 square root of 3. So in the y label, I'm putting 28 square root of 3. In the x label, I'm putting 14 square root of 3. For number 17, I label, so across from the 30-degree angle is x, the hypotenuse is 2x, and the last side is x square root of 3. Wherever I have a label and a number, I'm going to set those two equal. So x equals 15. Once you've solved for x, you plug it back into the formula anywhere you see an x. So this side is 2 times 15, which is 30. That answer goes in the y blank. This side is 15 square root of 3. That goes in the x blank.